Greetings, math fans. So this note sheet is basically vector application examples. All right, so we learned a little bit about vectors. Now we're going to start applying, using some of our knowledge of vectors, using some of our knowledge of law of sines, law of cosines, a lot of little things that we're going to be using here. All right, so let's start out with the first problem here. Shannon is pushing a 2,000-pound car up a hill with a 4-degree slope. How much force is required to move the car? Okay, so let's take a look what we have. First of all, let's draw a nice little incline here. It's a right angle, and it's a 4-degree slope. And let's just draw a car right on this incline here, and this weight of this car is going this way, and this is 2,000 pounds. Okay, and I want to know how much force is required to move the car. So I'm going to kind of draw the arrow here, but just to make it almost easier, I'm just going to move that arrow here. In fact, I'll do it in a different color so you can see it easier. I want to know how much force we're putting on that box or on that car so we can move it. All right. Now here's the deal, math fans. Couple things. We're going to be able to draw a triangle here. And do you guys agree that I can take this and I can draw that vector here? And what allows me to draw that vector there? Well, remember what I told you back in the day? You can take a vector, and as long as it's pointing in the same direction and has the same magnitude, you can move it anywhere you want. All right. So that's exactly what I did. I moved that vector from there to there, and look what that causes me to draw. Oh man, that's so sweet. Okay, another right triangle. All right, so let's talk about a little bit about this triangle and kind of put some things together, because truly I am looking for this value right here, this value x or f, whatever you want to call it. Okay, so let's kind of see what we have. Do you guys agree? Well, first of all, again, these are all right angles because it's a vertical line and a horizontal line, right? If that's 4 degrees, do you guys agree that this is this little angle right here is 86 degrees, right? 90 minus 4. And so if that is 86 degrees, and let's see what else we can do here. That means this angle back here, because again, this is going to be a right angle again, right? So that's also 4 degrees. That's kind of what I'm looking for. If that angle is 46 degrees, this side here is 2,000, and I'm looking for x, what do I use? Now, I know some of you guys might be saying, well, we can use law of cosine or law of sines, right? Yeah, you can. How about just a little right triangle trig here, right? Can't we just say sine of theta, which is sine of 4 degrees, equals opposite over hypotenuse, right? That's the hypotenuse across from the right angle here. That's pretty easy. And then I cross multiply, I get x equals 2,000 sine of 4 degrees. So x comes out to be 139.5, and then our units are pounds. Now, here's another thing. Does this make sense? Okay, it's barely a little bit of a slope. 4 degrees is not much. It's a 2,000-pound car. Is it going to take you much to push that car? Probably not a lot. I mean, 139 pounds is not trivial, but compared to a 2,000-pound car. But think about it. It's just a little bit of a slope. It's like, have you ever tried to push a car and it's on like almost a 0-degree slope, right? It's even kind of tough to get that thing going. But if it's on a little bit of a slope, all of a sudden it gets a lot harder to push it. Okay? But anyway, this is the setup. Very, very important problem. You guys need to know how to do this kind of setup for anything where you're pushing something up a hill. Okay? Very important. All right, number 2. Ryan and Nikhil are trying to pull Mr. Curtis into the pool. Ryan pulls on one of his arms with a 200-pound force, while Nikhil pulls on the other arm with a 250-pound force. The angle between Ryan and Nikhil is 40 degrees. How much force does Mr. Curtis need to exert so he doesn't go into the pool? All right, so let's draw the triangle, or let's draw the parallelogram. Okay, so Ryan is a 200-pound force, and Nikhil, he's going to be 250 pounds. And the angle between them is 40 degrees. Okay, how much forces do I need to exert so I don't go in the pool? Well, here's the deal. I'm looking for, I'm going to draw it in red here. I'm looking for this resultant vector. So what I'm going to do is I'm going to draw, it's basically I'm drawing a parallelogram. We've talked about this already using the parallelogram method. This is where it comes in handy, math fans. Okay? And I'm looking for basically that value right there. So we have to kind of use some of our properties of parallelograms, if you guys remember that. And we talked about that already. A parallelogram. Two really important ones we're going to use here. First of all, consecutive angles are supplementary. And then opposite sides are congruent. Two huge things for these parallelograms. Okay, so kind of what I'm trying to do here, math fans, is I'm trying to really get one triangle. Obviously, we're in the triangle chapter. Trying to get one triangle. So do you guys agree this is 250? So this is also 250. Opposite sides are congruent. If that's 40 degrees, do you guys agree that this angle right here is 180? 180 minus 40, which is 140. And I'm looking for x. Well, I have enough information here now, math fans. Here's the picture. So this is 200. This is 250. This is 140 degrees. And this is x. All right, so what am I going to use to figure out x? Well, I can't use law of sines because I have no opposite ratios, so I'm going to use law of cosines. So it's x squared equals 200 squared plus 250 squared minus 2 times 200 times 250 times cosine of 140. Please make sure when you're using law of cosines, you use cosine. Okay? Anyway, we do all our work here, take the square root, and we wind up getting x equals 423.2 pounds. Okay? That's that vector. That's how much I would have to pull against Nashil and Ryan in order not to go in the pool. And think a little bit logically, too. That kind of makes sense. And as that angle gets farther and farther apart, I have to pull less because they're going to be kind of like pulling against each other. Right? If they were standing behind each other, one behind the other, like in a tug of war, I would actually have to pull the total 250 pounds against them, plus the 200. So I would have to pull 450 pounds total against them, right? Okay, but then here they're 40 degrees apart, so I pull a little bit less. All right, that's not too bad. All right, let's look at number 3. Kind of a boring problem. But a force of 100 pounds makes an angle of 60 degrees with the second. The result of the two forces makes an angle of 35 with the first. Find the magnitudes of the second force and of the resultant. So it's just a matter of drawing the picture here. We've got two forces, so let's even just draw them. In fact, you know what? Let's just draw our parallelogram because we have a resultant force. Just makes it a lot easier. Okay. First of all, this first force is 100 pounds, and it makes 60 degrees with the second force. The resultant of the two forces makes a 35 degree angle with the first. So this is 35 degrees. Find the magnitudes of the second and of the second force and the resultant. So we'll do another color here. It's getting very exciting. We'll call this X and we'll call the second force Y. Okay? So let's kind of transfer some stuff up to the top triangle because I just labeled that Y on top, and it's a little bit easier. So do you guys agree if that's 100? Then this is also 100. Okay, and let's see, that's 60 degrees. The whole thing's 60, and that's 35. So do you guys agree that this angle right here is 60 minus 35, which is 25 degrees? All right, and of course, if the whole thing is 60, this angle right here is 180 minus 60, which is 120. And then I can figure out this angle, right? Because I know those two angles, and if I subtract from 180, 180 minus 25 minus 120 gives me 145, so this is 35 degrees. So really my triangle here, math fans, looks like this. this is 25 degrees. This is 120, and this is 35 degrees. Okay, not too bad. And then this is our y, this is our x, and this is our 100. Okay, so we got everything. Now, what are you going to use? Well, we have an opposite ratio here. We have the 25 and the 100, so let's use law of sines. So it's going to be 100 over sine of 25. And let's find x first. So it's going to be x over sine of 120. And some of you guys are saying, whoa, you can't do sine of 120. That's the largest angle. But remember, math fans, I'm not finding the largest angle. I'm using the largest angle, and that's okay. All right, so we cross multiply and divide, and we wind up getting x equals 204.9 pounds. Okay? And let's do y now. So we're going to do the same ratio, 100 over sine of 25 equals y over sine of 35. So I cross multiply, and I get y is equal to 135.7 pounds. Okay, so of course x being our resultant, and y being your second force. Okay, not too bad. So just using law of sines for that one. All right, so now these are my favorite problems. I really like these. These are airplane problems. It's Dan is flying a plane at a speed of 600 miles an hour on a bearing. Up, whoop, 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 bearing problem, 165 degrees. All right, so let's draw our dotted line here, and it's 165 degrees. And let's label. This is 165 degrees, and it's 600 miles an hour. Okay? There's a strong 30-mile-an-hour wind that hits the plane. It is coming from a direction of 250. Kids always get confused when it's like a word from or towards, whatever. If you're not sure, try the word north in its place. So if I said it's coming from the north, what do? Don't you go to the north and then go south? You go to that direction, go to that angle, and go the other way. So I'm coming from the north, I go to the north, and I go south. So what I need to do is I need to draw a dotted line here. Okay, that's going to hit that. And it's coming from, so let's draw this here. Do you guys agree that this guy right here, it's coming from 250 degrees? And that is going to be a 30-mile-an-hour wind. Okay? So does that make sense? So if you think about it, here's the plane, right? The plane is that top arrow, and it's flying that direction, and then there's a wind hitting it. Okay? And isn't it going to push the plane like more to the right? Well, if you realize, math fans, you can't have a vector like this, right? That's like tip to tip. Never have a tip to tip vector. It's always tip to tail. So what I'm going to do is I'm going to take that vector and I'm going to draw it here. That's the wind, right? So it's actually blowing the plane to its new course. The red line, first of all, this black line here, and let's actually maybe even make it green. This line is the vector that I drew, but it's pushing it. Remember, you can redraw a vector any way you want. So I'm going to redraw that vector from the green to the red because I want to go tip to tail. And then the blue vector is my resultant vector. Okay? So you got to kind of get the vectors correct. Don't do tip to tip, though. That's not what you want to do here. Okay? Okay, so now the deal is we need to figure out some information about that triangle. Well, first of all, I want you guys to understand that, let me actually draw something in here. This is the angle that I want. I put it in gray. Okay? Because if you look at let's draw another triangle. Kind of redrew that. I know this 600, and I know this 30 here. I can't really, this is not going to help me and this is not going to help me because I don't have enough information, okay, to figure out those two angles. Here's what I have to do though. I need to use pretty much both of the given angles. So I need to use this angle and I need to use this angle somehow to figure out this angle right here. It's always going to be, for these plane problems, always going to be the angle between the two sides, basically. Okay, so let's talk about how we're going to use that. Let's kind of go each angle at a time. So do you guys agree? I have 165 degrees here, and what I'm going to do is, what part of that triangle can I? What can I do with that 165? Well, do you guys agree the 165 here and this angle here, they're on the same transversal, and look at the parallel lines. So it's kind of like, here's my two parallel lines, and this is 165, and so this angle, isn't that just going to be 180 minus 165, which is 15 degrees? Okay, because they're same side interior, so this angle here is going to be 15 degrees. Well, that's cool. Let's talk about this angle now, because that's part of it. That's one part of the angle. How about this part right here? Well, how do I get that one? Again, I got to use the 250 now. You only use one angle one time. So I use the 165 to figure out that 15 degrees. Now I want to figure out that other green angle. And do you guys agree that it's 250 degrees? Right, this is 250 degrees all the way around, right from here to here, right there to there, right? 250 degrees. So basically, what can I do here? What can I do with that 250 degrees? Can I subtract 180 degrees? Do you guys agree this line right here is straight angle? So if I subtract 180 degrees, that's going to leave me with this part left over. Do you guys agree with that? Which is what I want. So I'm going to do, that red angle is going to be 250 minus 180, which is 70 degrees. So that red angle right here plus this other red angle, 15 degrees, gives me 85 degrees, and that's what this is right here. Okay, this takes practice. It really does. It's not like super easy to do this. You got to work at it. Okay, but you're always looking, kind of the key here is you're looking for supplementary angles, which in this case, that last angle, that was a supplementary angle. You're looking for same side interior. You're looking for sometimes alternate interior. Okay, but you gotta think of the properties, especially with parallel lines, what you're doing here. Okay, so once I have the triangle, the picture is actually the hardest part to draw, because once you have the triangle, it's actually really easy to solve it. Don't you guys agree? I mean, think about it. I'm looking for that x, and I have side angle side. Well, I'm going to use law of cosines. So x squared equals 600 squared plus 30 squared minus 600 times 30 times cosine of 85 degrees. So x comes out to be 598.1 miles per hour. Okay, not bad. That was the first part. Find the resulting, actually that was the second part. Find the ground speed. That's the new speed of the plane. Okay, the course, do you guys agree that the plane is going 165 degrees right now? What happens when it pushes it to the right? What happens to that number? Do you guys agree it goes like 165, 164, 163, do you guys agree it's getting less and less and less? So what I need to do is I need to figure out this angle right here, this theta. And once I get that, then I need to subtract it from 165 because it's getting less and less and less. If the wind was blowing the other way, it would be more and more and more. So anyway, how do I get that theta? Well, I have an opposite ratio now, right? I have the 85 and the x. So can I do 598.1 over sine of 85 degrees equals 30 over sine of theta. Okay? Cross multiply, take the inverse sine, and we get theta is equal to 2.9 degrees. And remember, it's pushing it less. It's going 165, 164, 163. It's getting less and less and less. So my new theta is going to be 165 minus 2.9 degrees, which gives me 162.1 degrees. Okay, that's my new course. All right, let's try another one here. Starting at the Conant Yacht Club, Shivani sails 15 kilometers on a bearing of 120 degrees. All right, so let's draw our nice little friendly picture. First of all, you see the word bearing, going 15 degrees, or sorry, 120 degrees, like that. So this is 120, and she's going 15 kilometers. Then realized she must go to Marathon to pick up some trig books. She changes the course and sails 40 kilometers on a bearing of 325. So she's here. That's why you're putting it on the tip, and she's going 320 kilometers. So you guys agree this is 320? Because 270 is to the left, and then it's a little bit more. So 325. Okay, and then and she's going 40 kilometers. Then it says find the distance from Math Island to Conant Yacht Club. So we're looking for this distance right here. Okay. So if I have to kind of look at my picture real quickly here, it's kind of what you have. We're going to use the angles in a second. But do you guys agree this is 15 kilometers that she sailed? And then she's going 40 kilometers. And so probably what we're going to be doing here, math fans, we're looking for this angle right here. Okay, the angle between the two sides. So let's do it. Well, let's look at the 120. Do you guys agree? It's kind of the same thing as before. That 120, again, it's that transversal. Let me put that in a different color. This is the transversal that goes with the 120. So do you guys agree that 120 and this angle right here are supplementary? So this angle right here, 180 minus 120 equals 60. Now that's not this angle that I'm looking for. It's part of that angle. And don't you guys agree that I actually have to subtract, from that blue, I have to subtract the green. And that would give me the angle. And look, let's use the other angle. Do you guys agree that 325 is almost all the way around except for that little part right there? So can I say 360 minus 325 gives me 35 degrees? So that green part is 35 degrees and the blue part is 60. So do you guys agree that the total is going to be 60 minus 35, which is 25 degrees? So this angle is 25 degrees. Sweet! Now I can do everything. Okay, once you know that, you use law of cosines. So we're going to call, we'll call this x on this side. So it's x squared equals 15 squared plus 40 squared minus 2 times 15 times 40 cosine of 25 degrees. So x comes out to be 27.2 kilometers. Okay, that's how far Shivani sailed from Math Island to Conant Yacht Club. So then there's no angle for this one. Okay, we're doing more problems like this. Even the homework has got a lot of problems, but it's a lot of practice and drawing an accurate picture and drawing those bearing lines and thinking of, like I said, alternate interior angles, same side interior, supplementary, a lot of different things to think about. So stick with this, guys, but you got to get practice and do the homework. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.